aeroplane has 6 seats in each row. And 1.1 says, how many possible arrangements are there for 6 people to sit in a row of 6 seats? 6 people sitting in a row of 6 seats. It means there are 6 seats and 6 people are supposed to sit on it. How many possible ways are we supposed to have? Okay. Now, if you check this one, if you have already watched the first and the second video, you will know what I'm talking about better because I explained it much there. Okay, we have 6 seats. So 1, 2, 3, 4, 5, 6. 6 seats. And 6 people are supposed to sit on this seat. How many number of ways that they can sit on it? Now if you take the 6 seats or the first seat, any of the 6 people can sit on it. Alright, so we have 6 ways for people to sit on that one. Then the second one, we have 5. One person has been used in the first seat, so it will remain with 5 people, and those people can sit on this. Any of them can sit on it. So here will be 5 and like that, and to go up to 1. Instead of writing all this long strip, you just write 6 factorial, which will give us 720. Okay, now how do you press this on the calculator?
God would bring honey out of the rock for me.
Now, to press this on the calculator, it's going to be 6, and it gives us 720. Alright, okay, let's look at the next question. Koliswa, Agnes, and 4 other passengers sit in a certain row on a Banana Airway flight. In how many different ways can 6 passengers be seated if Koliswa and Agnes must sit next to each other? So it means Koliswa and Agnes must be together. Koliswa may come first and Agnes will come second, or Agnes will come first and Koliswa will come second. Okay, so that will be the sitting arrangement. So if you check here, Koliswa, Agnes. Then we have 4 other passengers. 4 other passengers. So that one I call it passenger 1, passenger 2, passenger 3, passenger 4. So this is Koliswa, Agnes, passenger 1, passenger 2, passenger 3, passenger 4. These are the 4 other passengers. Alright. So in all we have how many passengers? 1, 2, 3, 4, 5, 6. Because we have to include Koliswa and Agnes. They are also passengers. Okay. Now the question says, how many different possible way these 6 passengers be seated if Koliswa and Agnes must sit next to each other? If Koliswa and Agnes sit next to each other, I'm just going to give Koliswa and Agnes. Alright, so we consider them as one block. You count them as one block because they must sit together. So here we are going to count 1, 2, 3, 4, 5. It's 5 factorial. And if you check here, Koliswa and Agnes, they may swap. That is, Koliswa may come first and Agnes may come second, or Agnes may come first and Koliswa may come second. They will swap. So that one is going to be what? 2 factorial. Alright. So what are we going to do? For you to easily remember you count 1, 2, 2 factorial. Is that okay for you to easy to remember? So here we have to press this on the calculator. Let's press that on the calculator. So I'm going to delete the 6. So 5 times 2 factorial, and this one is going to give us what? 240. Okay, now let's continue. Matt and 5 other passengers are to be seated in a certain row. If seats are located at random, what is the probability that Mary will sit at the end of the row? Okay, let me split. Okay, we are continuing. We said Matt and 5 other passengers are to be seated in a certain row. If the seats are located at random, what's the probability that Mary will sit at the end of the row or at the end of the row? Okay, so it means we have Mary, then 5 other passengers, similar to the first one. All right, Mary and 5 other passengers. So here, if the seats are located at random, what's the probability that Mary will sit at the end of the row? So Mary may sit at the end of the row here, or he may sit at the end of the row here. So first, let's deal with the situation where Mary sits in the first, at the end of the row at the left. So you don't count it. That place it stays. You don't count. So you are going to have 1, 2, 3, 4, 5. Alright, I've explained this one in the first video much. So if you watch the first or the second, you get that. Okay, so here you don't count Mary here. So you count 1, 2, 3, 4, 5. That's 5 factorial. Over the total number, what is it going to be? 1, 2, 3, 4, 5, 6. 6 factorial. Okay, then Mary can also sit at the right, at the end. So you count total outcome 1, 2, 3, 4, 5, 6. That's 6 factorial. Then Mary here, you don't count it. It's 1. Alright, so you count this 1, 2, 3, 4, 5. You don't count this one. Okay, because the rest can swap around. This one cannot swap. It will remain there. Okay, then after you add it, if you add, you are going to get this. You can also multiply it by 2. It will still give you the same answer. So let's add this. We have 5 factorial for 6 and 6 factorial plus 5 factorial 6 factorial. That will give you 1/3. Alright. Okay, now I hope you are copying this. Make sure your scribbler is there or your notes is there. You write in. Alright, you take notes. Okay, 5 boys and girls go to the movie. They are all seated next to each other in the same row. One boy and a girl are a couple and want to sit next to each other at the end of the row of friends. In how many different ways can the entire group be seated? In how many different ways can the entire group be seated? Now, if you check, we have 5 boys. So the boys 1, 2, 3, 4, 5. 4 girls. The girls 1, 2, 3, 4. They said in how many ways, different ways, can the entire group be seated? If one boy and a girl, a boy and a girl, they are couple, they want to sit together, they want to get separated. Alright. So the boy and the girl, one boy and a girl, a couple want to sit together. So here you put them together, boy and a girl, then you count them as one block. So what are we going to have? 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. Then we have this boy and a girl, they can swap around because they are moving together. So a boy can sit first or a girl can sit first. So here we are going to have 2 factorial, 1, 2, which is 2 factorial. Then this one also, remember the boy and the girl, they can sit at the left at the end or at the right at the end. Alright, so here also we are going to have 1, 2, 3, 4, 5, 6, 7, 8. Count this as 1, 8. So 8 factorial. And the boy and the girl, they can swap. So it's going to be 2 factorial. 1, 2, 2 factorial. So you can add it. If you add, you are going to get this one. You can also multiply it by 2. So let's add this. 8 factorial times 2 factorial plus the same thing times 2 factorial. We are going to have this one. Okay, let's continue. If all the friends are seated randomly, calculate the probability that all the girls are seated next to each other. All the girls. So the girls must sit together. So here we still have boy, 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 5 boys, 4 girls. The sample space. The sample space is the total outcome, number of total outcome, total number of people. Alright. How they sit together, the arrangement of total number of people. So here, what are we going to get? You count 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 factorial. I've done the explanation in those videos, so you go there and watch. Okay, now this one we are going to have all the 4 girls sitting together, because the question says the girls are seated together. Girls are seated next to each other. So all the girls seated together. A boy may come in front and all the girls may sit together. 2 boys may come in front and all the girls may sit together like that. Alright, but I've only brought one position and I'm going to work on that position to get the answer. So here, the girls are seated together, so you count them as 1. The boys, if they are seated together, you count them as 1. But this one is only the girls that are seated together, so I'm counting them as what? 1. The boys, I'm not counting them as 1. So this 1, 2, 3, 4, 5, 6. 6 factorial. And these girls, they are 4. They can swap around. Alright, so that's going to be 1, 2, 3, 4. 4 factorial. Let's press that on the calculator. If you press this on the calculator, 6 factorial times 4 factorial. And what is that going to give us? It's going to give us this one. Okay. So probability is number of all the girls seated together over the sample space. Okay, over the sample space. So here we want all the girls seated together. This is all the girls seated together. 17,280 over the sample space, and our sample space is what? 9 factorial. If you press this on the calculator, what are we going to get? We are going to get 17,280 over 9 factorial. So this gives me 1. Okay, so this is going to be your classwork. You do it for me. Look, take your time, copy it, pause the video, copy it nicely, then continue like that. I'm moving slowly. You pause the video, you copy it nicely. Pause the video, copy it nicely. Alright. When you are done copying, you continue like this. Pause the video and copy it nicely. Are we together? I hope you are doing the right thing now. Okay. So I know you are done copying now. So let's continue. Pause the video. Copy this.
All the evil powers sitting on my promotion.
Copy this one.
In Jesus'
They are
name.
all your assignments. Do it
Jesus'
nicely
name.
for me. Alright. You are great. You know how to do it. You can do it because you are intelligent. You must always believe in that. Okay. Now we are going to look at another example. A 5-digit code is created from the digits. These are the digits 2, 3, 5, 7, and 9. These are the digits. How many different codes can be created if repetition of digits is not allowed in the code? Repetition of digits is not allowed in the code. We can repeat the digit. That is what the question is saying. If we can't repeat the digit, I've written the digit here. So if you use it in the first space, you can't use it in the second space. So how many digit code are we creating? 5. 1, 2, 3, 4, 5. It was said in the question. Let me show you. 5 digit code. So here, this 5 digit code, what are you going to do? Now the question says repetition is
In your anger,
allowed.
and fight my war for me.
Repetition is not allowed. So if I use it in the first space, I can't use it in the second space. So it's going to be what? 5 factorial. Alright? Good. So 120 is going to give us 120. Then the next one is repetition of digit is allowed. So you can repeat the digit. If you use it in the first space, you can use it in the second space. So here I can use it in the first space, second space, third space, fourth space, and the fifth space. And this one is going to give us what? 5 factorial. How do you press? Sorry, 5 to the power 5. This is not 5 factorial. This is 5 factorial. And this is what? 5 to the power 5. So 5 to the power 5. I know this one is not a problem for us. 5 to the power 5 gives us this value. Né? Okay. Now let's see a group of 3 South Africans, 2 Australian, and 2 Englishmen are staying at the same hotel while on holiday. Each person has his or her own room, and the rooms are next to each other in a straight corridor. If the rooms are allocated at random. Determine the probability that the 2 Australians will have adjacent room and the 2 Englishmen will have adjacent room. So Australians and Englishmen, all of them must have adjacent room. Okay, so let's see how we are going to do it. We have 3 South Africans, 2 Australians, 2 Englishmen. So I've summarized the information here to help me to answer the question. So the question says the adjacent room, it means the room of us, we should have a room of Australian followed by a room of Australian. Then Englishmen, they must follow each other. The rest, we don't care the arrangement. South Africa can be in front, and the 2 Australians and 2 Egyptians can be together, and the rest will follow. Or 2 South African can be in front, and Australian, Englishman will follow, and the rest will follow. That is South Africa will follow. Like that, alright. But I've written only one arrangement here, and I'm going to use it to answer. How do we do it? Good. These ones, you count them as block. So you have 1, 2, 3, 4, 5. 5 factorial. Alright. So these ones are what? Block. Let me put them together as block. They are block. This is a different block. Okay. Now, so I'm counting them as what? 1. So 1, 2, 3, 4, 5. 5 factorial. Now these 2, I can swap them around. This A may come first and this will come second, or this may come first and this will come second. So what is it? 2 factorial. The shortest way, the simplest way of remember is 2 factorial. 1, 2. 2 factorial. The same thing can happen to this one. So this is also what? 2 factorial. 1, 2. 2 factorial. How do you press 2 factorial on the calculator? Five times 2 factorial times 2 factorial. And this one is going to give us what? 480. So this will give us what? 480. Okay. Then what are we going to do? Our sample space is going to be what? 7 factorial. How did you get that? 1, 2, 3, 4, 5, 6, 7. 7 factorial. And the probability is number of successes or number of events occurring over the sample space, the total outcome, number of total outcome. So this, if I press this on the calculator, what am I going to get? Let's press that on the calculator. The scale of using the calculator is important. Alright, so let's learn how to use the calculator well, because it answers most of the questions for us. Okay, so here we are going to have 6. We are going to have 7 factorial, and if I press that, I'm going to get 2 over 21. Okay, let's look at the next question. The cards below are placed from left to right in a row. So these are the cards: 1, 2, 3, 4, 5, 6. 6 cards. They are placed from left to right in a row. So that is the description. Okay, so the cards are placed from left to right in a row. In how many different ways can this 6 cards be randomly arranged in a row? Now check this: 1, 2, 3, 4, 5, 6. Alright, this card, how many ways can we arrange it? This may come first, this may come second, like that, and it follows like that. How many ways? Good. If you do it practically, it's going to take long. So the shortest way of doing it, how do you do it? Is going to be what? 6 factorial. How? Count 1, 2, 3, 4, 5, 6. 6 factorial. That is, you have 6 spaces. 1, 2, 3, 4, 5, 6. The first will take 6. The second will take 5, 4, 3, 4, 6, 5, 4, 3, 2, and 1, which is 6 factorial. Okay. Which is going to give us what? 720. Then the next one: in how many different ways can this card be arranged in a row if the diamonds and hearts are placed together, are placed in alternating position? Alright, it means diamond come, hearts come. So these are the total number of cards we have. We have 3 diamonds, 1, 2, 3, then we have 3 hearts. Let's check the pictures. Diamonds, 1, 2, 3, they are 3. Hearts, 1, 2, 3. Alright. So here we have the diamond and heart. So we have diamond, heart, diamond, heart, diamond, heart. That's the meaning of alternating. Diamond comes, heart must follow, like that. So that's the meaning of alternating. So here you count all of them as 1. So 1 block, 1 factorial. And how many diamonds do we have? They can swap. This diamond may come first and this may come second, and follows like that. So we have 1, 2, 3, 3 factorial. Then the heart can also swap. This heart may come first and this will follow. This may come, follow, like that. So how many hearts do we have? 1, 2, 3. So this is 3. And it's going to give us what? 3 factorial. Let's press that on the calculator. Where is my calculator? Here you are. So we have 3 factorial, and this one gives us what? We have 1 factorial is 1. Let me just press. 1 factorial is 1 times 3 factorial times another 3 factorial. 3 factorial. And this gives us what? 36. We can multiply it by 2 because H or heart may come first and diamond may come second, like that. Is that this one diamond come, then heart follows. We can have heart following or heart coming first and diamond following, like this. Alright, so this will also going to give you the same answer, 36. So you add the 2. Alright, 1 block, 1 factorial, 1, 2, 3, 3 factorial, 1, 2, 3, 3 factorial. Gives us 36 plus 36, which is 72. Another way of doing it is you do the first one, you multiply it by 2. Okay, let's look at this one. If these cards are randomly arranged in a row, calculate the probability that all the hearts will be next to each other. All the hearts will be next to each other. So these hearts must be next to each other. They didn't say they must sit at the end. So they can be in the middle, they can be in front, etc. Alright, they must be next to each other. Okay, so here you count them as 1. So we are going to have 1, 2, 3, 4. It's going to give you that. So our probability is going to be the sample space. That's the number of successes over the sample space. So we know our number of successes to be this: 144, Our sample space is going to be 1, 2, 3, 4, 5, 6. 6 factorial. Okay, so here if I press this on the calculator, I'm going to get 1 over 5. Alright, let's press. One 4 over 6 factorial. So this gives us what? 1 over 5. Okay, then the next thing, Ben, Nklankla, Derek, and 6 other athletes take part in 100 meters race. Each athlete will be located a lane in which to run. The athletic track has 4 lanes. The athletic track has what? 10 lanes. So there are 10 lanes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lanes. Alright. Okay, but the lanes we have Ben, Nklankla, Owen, Derek, then 6 other athletes. Athletes 1, athlete 2, 3, 4, 5, 6. So this we want to calculate. Each athlete will be located in the lane which is supposed to run. The athlete track has 10 lanes. Okay, so the total number of arrangements, what is it going to be? It's going to be 10 factorial. Alright, 10 factorial. We want the total number of arrangements.
In Jesus' name, out of my life, out of my family, out of my job, out of my business, leave me now, in Jesus' name.
The total number of arrangements of people, of athletes. The track or in the tracks. So here you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. So it's 10 factorial, because we have 10 spaces. The first 10 people, 9, 8, etc. Okay. Then 4 athletes taking part in the event. Remember at the beginning we're talking about cards. Okay, now 4 athletes taking part in the event insist on being placed in lane next to each other. In how many different ways can the lane be allocated to the athletes now? 4 athletes taking part in the event insist on being placed in lane next to each other. In how many different ways can the athletes be allocated to the athletes now? In how many ways can the lanes be allocated to the athletes now? Okay, so here we have BNOD. What is B? B is Ben, N, Nklankla, O, Owen, D, Derek. Okay, so we have these ones. Then we have athlete 1, athlete 2, athlete 3, 4, 5, and 6. So, because there are 6 other athletes. Alright. Now, the question says, in how many ways can the lane be allocated to the athletes now? So how many ways? But this ones must sit next to each other. Because the question says 4 athletes taking part in the event insist on being placed next to each other. So you count them as 1. So this is going to be 1, 2, 3, 4, 5, 6, 7. 7 factorial. And these athletes, we can swap them around. So they are 4. 1, 2, 3, 4. So that's 4 factorial. When you press this on the calculator, you get this. Then the next one, if lanes are randomly allocated to athletes, determine the probability that Ben will be placed in lane 1, Klankla in lane 3, Owen in lane 5, and Derek in lane 7. Alright, so here we have lane 1. Lane 1 is for Ben. Lane 2, nobody. Is athlete 1. Athlete 1 may take, or athlete 2 may take, or athlete 3 may take. Any of the athletes, the A1s, they can take. Alright, so I just made one arrangement. Then lane 3. Lane 3 is Klankla. Klankla in lane 3. Lane 4. 1, 2, 3, 4. Lane 4, any of the athletes, athlete 1, athlete 2, or athlete 3, apart from Ben, Klankla, Owen, and Derek. Lane 5. Lane 5 is Owen. Owen in lane 5. Lane 5 is Owen. Lane 6, we don't know. Lane 7 is Derek. 1, 2, 3, 4, 5, 6. 6, any of the athlete can take. I decided to put A3 there for one arrangement. This is Derek. Then the rest of the lane can be any of the athletes. It can be A4, A5, A6. Alright. So these ones, they are stick there. Whether you like it or not, they must be there. So you don't count them. You are going to count only this one. 1, 2, 3, 4, 5, 6. They are 1. So you don't count them. So it's going to be what? 1, 2, 3, 4, 5, 6. 6 factorial. Alright, have you seen the difference between this and this? Okay. You can watch the first video. I've done a lot of explanation on this one. Né? Okay. Now let's see the probability that this arrangement is supposed to be. Determine probability that Ben will be placed in 1, the Klankla, 2, Derek, 7, Owen, 5. It's going to be number of successes, which is 7, 6 factorial over our total outcome. What's our total outcome? 10 factorial. How did you get it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have that one. Okay. So I will say bye bye.